Hey everybody, Mr. Reeves back with you, and we are looking at lesson 10.1 in the 6th grade math book, Modeling and Writing Expressions. So in a previous video, I went through the lesson. We talked about what an expression was, different parts of an expression, and we did some sample problems. In another video, I went through bar models and we looked at how to create bar models to represent expressions. And now in this third video, we're going to actually be working through some practice problems. All right, so these are practice problems from the lesson on Introduction to Algebraic Expressions. All right, here we go. So it says write each phrase as an algebraic expression. So 3 less than y. So the first thing we have to ask ourselves is what operation is less than. All right, so if we were to go back to that table we have, in fact, I'll go back there real quickly. This is something that you can turn to in your online textbook on page 263. These are words and phrases that you need to memorize. Basically, we see that less than goes with subtraction. But remember, less than means to subtract from. All right, so if we take a look at 3 less than y, that's going to be y minus 3. Anytime you see those words less than, you need to switch the order around. So rather than 3 minus y, it becomes y minus 3. Product, if you were to look on that table, product means multiplication. I'm going to put a subtraction sign right there. Product means multiplication. So the product of 2 and p, the best way to write it is simply to write 2p. Remember, 2 is the coefficient and p is the variable. All right, if you wanted to put a dot, you could put a dot 2 times p, or you can put parentheses. That also shows multiplication. All right. All right, write a phrase for each algebraic expression. All right, so what do we have right here? We have a plus. All right, that is addition, y plus 12. So what are some words we can use for addition? Well, we can simply write y plus 12, and that would be okay. We could also say maybe y increased by 12. Or maybe we want to say the sum of y and 12. There's going to be many different ways that we can take an expression and change it to words. So right here we have p divided by 10. So certainly we could just simply say that. P divided by 10. And that would be correct. Or maybe we would say the quotient. The quotient of p and 10. All right. And another way we might say this is 10 divided into 10 divided into p. 10 divided into p. Remember, when you're using that divided into, it's like less than. You have to switch the order around. All right. Hopefully you got a chance to watch that video on bar models, and we talked about dividing, and when you're dividing, that means to break up into 4 equal parts. So what I want to do is take this bar right here and break it up into 4 equal parts. I can only really estimate here right now. I need 3 lines to break it up into 4 parts. Okay, so this is just an estimate. If this were completely accurate, these would all be the same. So this is m divided into 4 equal parts, and each of those parts would be m divided by 4, or 1/4 of m. All right, that's what they were, but really all you have to do is draw those lines. There it is. That is the m divided into 4 parts. Okay, all right, moving on. Okay, it says the temperature in Redding, California is the same as the temperature in Fresno, California at T. So you see Redding has a temperature of T, so this whole bar is T. Fresno also has a temperature of T, so the whole bar is T. All right, by 9 p.m. the temperature in Redding has dropped 2 degrees, and the temperature in Fresno has dropped 4 degrees. So it's getting less, so it has to get smaller. So in Redding, it dropped 2 degrees. So I'm going to go right here and say that represents 1 degree. And then using the same size, hopefully that represents 1 degree. Fresno, on the other hand, dropped 4 degrees. So there's 1. And again, in a perfect world, these would all be exactly the same size because they represent the same thing. This is just a sketch. All right. So now what do I have? Now in Reading, I have T minus 2 left. And in Fresno, I have T minus 4. I don't know what that original temperature was for either. This one went down by 2. This one went down by 4. All right, but I'm going to go ahead and erase that because it says by 11 p.m. the temperature in Reading has dropped another 3 degrees. So I'm going to add 3 more. Let me go ahead and change the color to show that this is occurring at a different time. There's another drop, and there's another drop, and there's another drop, okay? So now let's look at what's left. Well, Fresno is still what it was, which is T minus 4. The whole thing is T. Take away 1, 2, 3, 4. We have T minus 4 left. Reading was originally T, but we take away 1, 2, 3, 4, 5. And what do we now have? Reading is now T minus 5. All right. So there we go. There's our bar models, and there is our expression right there. T minus 5, and Fresno is T minus 4. Okay. All right. Are the expressions that represent them equivalent? No, they are not, because T minus 5 is not equivalent to T minus 4. Not at all. Okay, here we go. Noel bought some boxes of water bottles for a picnic. Each box contained 24 bottles of water. If C is the number of boxes, write an expression to show how many bottles of water she bought. So what do we have here? We've got a box. All right. So this represents my box. And in each one of those boxes, there are 24 bottles. All right. And she has C boxes. So this is 1, right? So 1 would be 24. 2 would be 24 times 2, right? 3 would be 24 times 3. 24, by the way, 1 would be 24 times 1. So C boxes would be 24 times C. Does that make sense? All right, so the number of boxes she bought is 24C. Every box has 24 times C boxes tells us what our total would be. All righty, let's go on to the next page. All right, do a few more problems and then we will be done in this video. All right, write an algebraic expression with the constant 7 and the variable y. Remember, constants are just another names for numbers. Variables are letters to use to represent things we don't know that are changing. All right, so 7 times y, that would be an example. 7 plus y, that would be an example. 7 divided by y, all right, or what about y minus 7. So these are all algebraic expressions that contain the constant 7 and the variable y. All right. Okay, let's go through some of these real quick. N divided by 8. There we go. N divided by 8. P multiplied by 4. The best way to write that is put 4 in front. That's your coefficient. B plus 14. 90 times x. A take away 16. All right, here's that one where we have to be careful. When you see less than, you have to switch these around. K less than 24 means 24 minus K. Less than means subtract, but switch it around. 3 groups of W. 3 groups of W. That means W plus W plus W. All right, but that's the same as 3W. Actually, so either one of those would be correct for that one. All right. What about the problems that come next where they switch it around, where they give us the expressions and they want some words? Remember, these ones are going to have more than one correct answer. So this would be m plus 83, or I like to say the sum of m and 83. That's an 8. That's an 8, believe it or not. Okay. 42s. 42 times S is one way to say it. We could also say the product of 42 and S. All right. 9 divided by D, or we could say the quotient of 9 and D. All right, this one could be T minus 29, but I'm going to go back to that phrase I've been trying to get you to understand. 29 less than T. Do you see how they switched? 29 less than T. Again, when you have less than, the order switches around. 29 less than T. All right, this one could be the sum of 2 and G, the product of 11x, the quotient of H and 12. This one right here, again, I would like to say, I really want you guys to understand this. All right, K less than 5. Again, we're going to use that word less than, and we're going to switch the order around. Okay? All right, a few more problems, and then we're going to be done. Sarah and Noah work at a bookstore and get paid the same hourly wage. The table shows their work schedule for last week. All right, remember the amount of money you make, okay, the amount of money that you earn is going to be the hours worked, the hours times the rate, okay? Rate, the hours or the time. The rate times the time is going to equal your pay, okay? The rate times the time is going to equal your pay. And it says they make the same hourly rate, all right? And we're going to represent her hourly wage with W, or rate in this case is wage by hours. Hourly rate here, hourly, not rage, Mr. Reeves, wage. All right, so Sarah last week worked 5 hours, so she'd get W dollars for those 5 hours, plus she would get W hours for the 3. So her expression would be 5W plus 3W. Now, if you're going, well, wait, could I add the 5 and 3 and say that it was 8 and put 8W? Yes, that would be correct. All right, Noah did not work on Monday or Tuesday, but he worked 8 hours on Wednesday, so his is 8W. So now hopefully you're going, well, wait, those are equivalent, aren't they? And the answer is yes, they are equivalent. All right. And it says use models to justify your answer. All right, well, Sarah's would be, well, if we were actually going to do this, right, for Sarah, it would be W plus W plus W plus W plus W plus W plus W, and let me put another one over here, plus W, right? So here's her 3 W's, and here is her 5 W's, right? So 3W plus 5W. All right. Each hour she works, she earns W. And then, of course, what's his name? Noah is going to be, so hers, just to emphasize, is broken up into 3 plus 5, right? Whereas his, it's all in one shot, all in one day, W, 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 plus W, plus W, plus W, plus W, plus W. His was all in one day, right? She did Monday 3 hours, Tuesday 5 hours. His is all 8W, all in one day on Wednesday. Okay, hopefully that makes sense to you. All right, Mia buys 3 gallons of gas that cost D dollars per gallon. Bob buys G gallons of gas that cost $3 per gallon. All right, so how much you pay is going to be how much you buy the volume times the cost. All right, so Mia buys 3 gallons times D dollars. So hers is going to be 3D, right? Bob buys G gallons at $3. So his is going to be 3G. All right, what do the numeral and the variable represent in each expression? All right, so this 3 for Mia represents what? The number of gallons? And the D is the cost per gallon, right? That's for Mia. All right, this is for Mia. All right, let me use a different color here for For Bob. For Bob, G is the number of gallons, right? And 3 is the cost per gallon. So it's important to notice here that the constant for Mia was the number of gallons and the variable was the cost, but for Bob it was just the other way around. The variable was the number of gallons and the constant was the cost. Honestly, Bob's is a little more realistic because usually you know the cost of the gas. The question is not what is the cost, but how much are you going to buy. Wouldn't that be kind of interesting if they told you the price after you bought it? All right. Okay, I think I'm going to stop there with this lesson. If you have any more questions about how to do any of these problems or anything that you have a question on, feel free to contact me and let me know. All right, have a great day.